Good morning. I'm going to cover an innovative synthetic modelling environment that we were developed in the last couple of years, which uses S100, the Universal Hydrographic Data Model, the IHO, Universal Hydrographic Data Model, the next generation, which is S100, which I'll talk a lot about, and its role in situational awareness and navigational assurance. So I'll do the first bit, and then I'm joined by my colleague Mike Knott, who will cover the navigational assurance part of the presentation. So I'll spend the first 10 minutes covering through how we've developed the S100 environmental platform, which, as said, really is delivering enhanced situational awareness, which is important for autonomy. And we'll then cover, we've just completed a CORREG compliant assurance of a navigational system. We'll talk about that and its role going forward. Very quickly, BMT, about 1,600 people, 30 offices, 4 countries, been going since 1985. Our key markets, we're involved in designing consultancy, asset monitoring, defence and security acquisition, and environment and climate solutions, but the common thread is all maritime. So, just as a background, the current S57 standard for digital hydrographic data has been in use since 1992, with the last revision being in 2000. It's fundamentally limited in its application because it's primarily intended that the human is the end user. Now, moving forward, the Universal Hydrographic Data Model, or I'll call it S100 for short, is inherently more flexible. And it offers provisions such as machine readability, multiple coding formats, enhanced metadata provisions, highly gridded data and imagery, and time-varying data as well. So what we've done is we've taken an established field-proven navigational simulator, which is used around the world on ships and ashore. We've integrated with quite a novel hydraulic modeler to develop other components of the S100 data sets, and we fused them together. And I'll give you an example of its application in Plymouth. The work we did actually won the UK 2020 Admiralty Innovation Award. So we were very pleased with that because 9 countries entered, and I think there were over 5 companies got to the final, and we fortunately won that. But essentially provides a dynamic, much richer, machine-readable world, essentially delivering much more precisely navigation and situational awareness. I'm going to show a slide, because we work closely with the UKHO, and Neil's in the audience, of course, as well. We work very closely with the UKHO, not just in actually doing the work which won us the Admiralty Award, but since then we've been working with other ports and terminals and shipping companies and see how that can be actually utilised as S100 data on board ships. It's a brief demonstration of what the S100 world is. At its foundation, the S100 framework will be a series of machine-readable product catalogues that allow data standards to be updated and active systems to be very quickly updated going forward. There's a lot of reference there to various S100 areas, but principally we've been working in the areas of S102, which is bathymetry, ultra-granular bathymetry, S104, dynamic water height, again, ultra-granular dynamic water height development, surface currents, S111, and S129, which is next generation of uncrewed clearance management. So the platform we've used to actually fuse all this data is a system called REMBRANT, and it's now S100 enabled. It works in S57, S63, but it's been upgraded for this. It's been around for 30 odd years. It's used by probably over 100 ship and ports and pilots around the world. It's been used extensively in accident investigation analysis as well for digital forensics, which lends itself to the later part of the presentation on stress testing correct compliant systems in autonomous vessels. So the users there are the NTSB, the Dutch Safety Board, the UK MEIB, the Australians, the Singaporeans and so on, all have REMBRANT to assess accidents and then to look at lessons learned, to feedback that into future training requirements, which does lend itself quite well to the developing autonomy world. But it's standard stuff, full 6 degrees of freedom, 2 and 3D dynamic current flows, squad bank ship-to-ship interactions, the NC platforms that are automatically generate the interactive topography and bathymetry. It's also AS enabled, VDR, PPU enabled for pilots, and it has a very rudimentary decision-making interface. It's on board probably over 100 vessels, mainly cruise and LNG for the last 30 years for STCW. So it's been really stress tested, and so it's very field proven as well. And being used extensively shore and ships. We have over 2,000 man-years of operational experience on ships alone. So I'm going to get into some of the trial data. We've been working with the UKHO on getting hold of S102, the bathymetry, ultra-granular bathymetry, to demonstrate the benefits in e-navigation using much more highly granular bathymetry. So here's an example here of REMBRANT, Port of Southampton, S57 on the left, S102 simulation on the right. Essentially the S57 display formats adopt band ranges for navigation. This can render large regions seemingly unnavigable outside the safety area if the safety depth does not correspond to one of the contour levels. So if we're looking, for example, a safety depth of 11 meters, it would render the whole 10 to 15 meter bound out of bounds. But with such fine resolution, so you're picking up things like small wrecks that are just not visible on the S57 chart, with that being now removed, allows much more precise passage planning particularly. REMBRANT also predicts where the vessel will be ahead, which is actually an important issue as well. So, in the model, in the Admiralty Challenge, we talked about developing and integrating REMBRANT, and inside it has an advanced 3D hydraulic modeler as well, because at the moment, hydrographic officers are exploring S102, bathymetry, but things like S104, dynamic water height, S111, surface currents, and S129, undersea clearance, are just not mature enough. So we've used our own hydraulic modelers, which are again used all around the world, to develop equivalent data for S104 and S111. So basically we've merged the two together, we applied it to Plymouth, we've taken dynamic water levels down to 10 meter gridded and 5-minute temporal. So quite a fine hydraulic mesh, all calibrated against quite expansive in situ tidal sensors, so it's all calibrated. We modeled the seabed composition as well, because in an autonomous vessel, it may decide to deliberately ground to avoid a collision, and it needs to process the seabed composition as well. All the LiDAR terrain data was in there as well, so for example, rainfall in the previous days would affect dynamic water levels. The hydraulic model covers all of that, so you get actually very detailed dynamic water height data. Linked into AIS Live, e-notes to mariners, and ship routing information. So essentially, the hydraulic model we use is a BMT announced product. It's used all around the world. generally for flooding, urban drainage, tide, sediment transport. So it's very field tested as well. It now sits within REMBRANT. So REMBRANT can generate its own accurate hydraulic data. And it's been proven to be about 8 to 300 times faster than most of the products on the market, which allows us to develop, in Plymouth, we developed the full hydraulic model in 36 hours and calibrated it. That was a requirement of the competition with the Admiralty. So we did all that. So a model domain spanning 110 kilometers east to west, 50 kilometers offshore, to a depth of about 80 meters. We developed all of this, and it's progressively refined in the area where REMBRANT needs to navigate. So moving in on this, the hydraulic mesh, again, furthest offshore, getting much more granular as you move inshore. And here we've got an autonomous ferry that we'd already modelled, actually coming into Plymouth. The water's removed here, so you can see the bathymetry model, the S102 bathymetry. But effectively, the hydraulic model is developing the S104 dynamic water height data, the S11 surface current data, and it's actually monitoring under new clearance. So all that data has been taken on board by REMBRANT, it's fused, it's processed, and it's displayed. And on this trial, we had the Plymouth pilots actually with us, just looking at the realism of this, taking all the data in, to see, looking at the decision-making of the autonomous ferry coming in to see whether it could process all the S100 data and make reasonable decisions on there. We ran it for S57 as well, and frankly, the situational awareness generated with just S57 data was not sufficient. So, switching over to Mike now, what's interesting in here is S100 data really does provide enhanced situational awareness. And interestingly, the Mayflower autonomous ship here did use and process S100 data. It was actually S102 bathymetry data. So we've actually got quite a high-profile initiative here, which itself used basic S100 data in its navigational decision-making. So looking at how that feeds into autonomous assurance, Mike's going to talk through that now. So I'll hand over to Mike. Thank you.
Thank you. So good morning. So just to introduce myself briefly, I'm actually the autonomy lead for BMT. Coming into BMT about a year ago, my previous life was in the Royal Navy, where I was a Commodore, a ship driver and navigator by background. I spent most of the last 10 years developing future capabilities for the Navy. I was head of future capability. Part of that was to be the senior responsible owner for the autonomy programs that are coming through for the Royal Navy. So I was SRO for the future mine hunting capability, which is an autonomous mine hunting system, as well as Navy X, which many of you will have heard of. So we started Navy X to try and get after some of the difficult challenges here. So I really approach this from a point of view of an operator, and I know that James has set us a hard target, notwithstanding what's on the clock here. So I'm just going to spend 3 minutes just giving you a little insight into how we're thinking about applying some of the stuff that Phil's been talking about and what we've actually done. And then anybody who wants to pick up the conversation, our stand is literally just over there and we can pick it up afterwards. So our background as BMT, as Phil's mentioned, is very much in the maritime domain, working closely with regulators as well as sponsors of capability, so those that are purchasing capability to go through, as well as those that are providing. So we sort of sit nicely independently between the three, and what we're trying to do as a technical consultancy is to solve some of those great challenges. So what we've done is we've started to think about how does this data fusion system, which is a very hydrodynamically accurate model called REMBRANT, help us to get through that challenge of how we're going to achieve certification. I'm not going to recount what has already been said. There's been a lot of content already about the frameworks and the challenges around certification. Where we're approaching it from is how do we create the evidence that will allow you to go and get an appropriate certification for the capability that you wish to operate. So it won't be a pass or fail, it will be about working out what is an appropriate level of clearance for the capability that you wish. And we've approached it from the point of view of a valuable mariner. So in my Navy role, I used to both train and also assess ships' captains, for example. We would do that in a synthetic environment. We would do that against a number of scenarios, which would test the most likely and most dangerous situations, the common failings, the things that people get wrong. So rather than approaching this from the point of view of we're going to do endurance testing over every possible scenario, well actually that's infinite. So what we need to do is we need to say what are the edge cases and can we produce a level of evidence which shows equivalence. So we're talking about the basis of equivalence, so we do that in the REMBRANT simulator. It's very easy to integrate a system. We're not looking at data fusion here, we're looking at the step where a system has accepted that there is a potential collision or a navigational situation about to occur, and how is that vessel going to respond? Is it going to respond appropriately? Is it making mariner-like decisions? And by mariner-like decisions, I mean, is it observing good seamanship, and is it obeying the regulations as well? We won't go into the conversation we had yesterday about that. So it's progressive, it can be supervised by area, or by size, or by task. So in the same way as an officer watch will be cleared in class 2 at the very bottom end of his career, or will be cleared as an unlimited master mariner at the very top end of her career. It doesn't matter what level of assurance you're going to give here, but what it needs to be is appropriate for the task that we're doing. So we can model that. We can then also help develop the systems as well. I'm not going to read through the slide because of time, but please see me afterwards if you want more detail on that. And then just to quickly get on to sort of where we've actually got to, the key challenge, as I say, as I brought was, I've got this autonomous mine hunting capability. I need to get the people out of the minefield to realise the benefit that we need to deliver from this system that we've invested in. So we worked very closely with the Maritime regulators, the Naval Authority Group in the Royal Navy's case, to go through and work out exactly how we were going to do that. And so it was quite a neat thing to be able to continue when I came into BMT, to start thinking how we can assist that process. So we've worked with L3 Harris and Navy X quite recently to run a full certification package, and I'm pleased to say that that was successful. It was really helpful for the provider because they were able to see exactly how their system performed against the most common and most likely scenarios. It was very helpful for the sponsor of the capability because they were able to put together the evidence, and it was very helpful for the certification authority because they had a body of evidence against which to start making judgments about clearance. So we're not saying that we're going to issue the certification, but what we will do is we will help create that body of evidence that allows the appropriate clearance to be issued for the type of vessel and the task that's required. So that was a very quick whistle-stop tour. Almost got you back on time, James.
No, you're on time, you're fine.
Delighted to pick up any questions and to definitely chat afterwards.
Okay, so let's move over to the floor for questions. Do I see a hand up without a camera on the end of it? Anybody want to fire a question into the BMT team? Yeah, can we have a mic up in the front left here, please?
Thank you very much for the excellent presentation. My name is Christian Kabel from Datsun. It's one question regarding the scenarios, 30 scenarios. You did discuss these with regulators, class society, flag states, or is it's a proposal from your side that these are sufficient for certification?
Yes, so again, it's what we're saying is that if you wanted to test every conceivable, feasible situation, you're actually talking about an infinite range of scenarios, an infinite range of sea states where they're accepted. So what we've done is we've looked at, and there's quite a lot of evidence about where the common faults are, and we've created scenarios which test those common faults. So you're looking at edge cases, you're looking at most likely scenarios, in order to be able to contain the test within a reasonable period of time. So it's not the premise of repeatability testing. What we're taking is much more how would a human be tested. So those scenarios were then agreed with the Naval Authority Group in the case of the Royal Navy. We've also been talking to the Maritime and Coast Guard Agency. Rob Gale's not here today, unfortunately, but they're also looking very closely at how we're doing this because we want applicability across not just navies but also across to the merchant sector as well. And so in the same way as we talk to the certification authorities and the P&I firms, and what they're after is to be able to make a risk-based decision on the system which is making mariner-like decisions. And so it's a system of equivalence rather than full range testing you do in a different range of things.
Okay, thank you. Do we have one more question before we break for coffee? Where's the lure of caffeine? Oh, hang on. Do we have one more question from the floor? I think we're going back to where we just come from. Hello, Walter.
Thank you. Second question, regarding the flow simulation, you're suggesting that this is needed for precision maneuvering, that you do online flow prediction while you navigate? Is that what you propose?
I'll talk about it from applicability, because the point that might not have come out is, I think if you start to think about what we heard from Andy Miller earlier, reference live updates from sonar data, for example. If you've got a very good synthetic model, and I'm always very nervous of using digital twin because it's so overused and misinterpreted. If you've got a very good synthetic model and you've got real-time live updates, then start to think about how that can be useful if you then start to lose sensors, particularly things like GNS denied environments. So what we can do is we can actually fuse real-time and modelling data, update the model accordingly, get that fixed, and then be able to present a system which could either rehearse or potentially even navigate a vessel from the synthetic environment itself.
And REMBRANT is a real-time navigation. It is developed to take in live data and make decisions quickly.
Okay, I think we'll stop there because the lure of caffeine, but also the chance to network is overpowering, really. Can you show your appreciation for the two guys, Mike and Paul, from BMT?